Okay, here in Module 7, we are going to actually look at a different series of equations and graphs which are called the conic sections. But before we get to those, we have to kind of have some background knowledge and some skills to be able to look at those conic sections. And so those two things we're going to look at are the distance and the midpoint formulas. So essentially, if I have 2 points on the plane, how far is the distance between them? That would be the distance formula. And then also, if I have 2 points in a plane, what is the middle of those 2 points? So the distance formula is simply this. It says given 2 points, x1 and y1, and x2 and y2, located on the coordinate plane, the distance between these 2 points is given by the formula d equals x1 minus x2 squared plus y1 minus y2 squared. The proof of this is actually a pretty easy one that you can see from geometry. So we'll do a quick little proof. So I'll take my coordinate plane. So I'll take a point here, which I'll call x1, y1, just the first x and the first y. And I'll call this point up here x2 and y2. Doesn't matter. And then I'll make this segment between them, and we'll call this the distance, because this is the distance between the 2 points. Well, if you think about it, what I could do is I could form a right triangle here in the coordinate plane. Now this distance is simply going to be the top y minus the bottom y, so in this case it's y2 minus y1. And on this side, if you go over x and you subtract the closer x, that gives you the distance here, so the distance here is going to be x2 minus x1. So now if I do my Pythagorean theorem, we know d squared equals x2 minus x1 squared plus y2 minus y1 squared. Now I've switched the y2 and y1, it doesn't really matter, those are just generic subscripts. You could switch x1 and x2, it doesn't particularly matter. And then I just take the square root of both of these sides. So d will equal the square root of x2 minus x1 squared plus y2 minus y1 squared. Or if I want to switch it, the distance could simply be x1 minus x2 squared plus y1 minus y2 squared. Because those are just arbitrary points. It doesn't matter which one comes first, which comes second. Okay. So a pretty easy formula to derive, but a formula that we'll use quite often. So in this first example, it says find the distance between the following 2 sets of points. -2, -3, which is way down here, and then 4, -8, which is down here. So I want to know this distance here. So what I'll do is I'll call one of these points x1 and y1, and one of these points x2 and y2. It doesn't matter, but just for simplicity's sake, I'll go ahead and call this one x1, y1, and this one x2, y2. But again, that's an arbitrary selection. That's why the formula didn't matter. And then if I look at my distance formula, distance equals square root. So I'll take x1, which is -2, minus 4 squared, plus y1, minus 3, minus -8 squared. So we're going to have the 2 negatives on that second part. So the distance will equal the square root. Now this will just be -2 minus 4, which is -6 squared. -3 minus 8, 2 negatives will make our positive. So we have -3 plus 8, which is 5 squared. -6 squared is 36 plus 25. 36 and 25 is 61, so this is the square root of 61. So the distance between these two is the square root of 61. We could try to simplify that. It doesn't simplify because 61 doesn't break down. Its approximate distance would be about 7.81 units. So there's about 7 units, almost 8 units distance between these 2 points. Okay, let's look at another example. It says in triangle MNP with vertices 1, 4, so let's put some of these vertices on our triangle. 1, 4, there's M. Negative 3, negative 2, there's N. And 4, negative 3, which is right there, is P. So there's my triangle on my plane. So we want to know, is this triangle isosceles? Now isosceles triangles, remember, have two sides the same length. So all we'll have to do is find basically the length of each side. So first I'll start with side MP. So MP is between the points 1, 4 and 4, negative 3. So I'll find the distance between those. So this is x1, y1, this is x2, y2. So the distance will be the square root of 1 minus 4 squared plus 4 minus negative 3 squared, which will be addition. So this is negative 3 squared. This becomes 4 plus 3, which is 7 squared. So this is the square root of 9 plus 49, which is the square root of 58. So this side length MP is square root of 58. So that's good. So that's the one distance. Now if we have another side that matches it, we know it's isosceles. If not, it's not. So next I'll do side NP. Now, NP has the points negative 3, negative 2, and 4, negative 3. And again, we'll arbitrarily pick those to be x1, y1, x2, y2. So if I use my distance formula, I get negative 3 minus 4 squared plus negative 2 minus negative 3 squared. So negative 3 minus negative 4 is negative 7 squared plus negative 2 plus 3, which is 1 squared. So negative 7 squared is 49 plus 1. So this is the square root of 50, which we could simplify, but I'm just going to leave it like this. So now we have one side which is square root 58, one side which is square root 50. So not isosceles yet. So now our last side we'll do is MN. MN. So I'll do the distance formula again. So M is 1, 4, and again doesn't matter. And N is negative 3, 2. And I'll call this one x1, y1, this one x2, y2. So the distance is going to be 1 minus negative 3, which will be added, plus 4 minus negative 2, which will be added. So this is going to be 1 plus 3, which is 4 squared. This is going to be 4 plus 2, which is 6 squared. So this is going to be the square root of 16 plus 36, which is the square root of 52. So if you look at these, none of these sides are the same. So we would say this is not isosceles. And if you remember from your geometry, we call it scalene. All the sides are different. But a good practice in using our distance formula for a lot of these things. Okay, let's look at this example. We're trying to find k if the distance between these 2 points is 4. So really what we know in this problem is we know what x1 is, we know what y1 is, we know what x2 is, but we don't know what y2 is, but we know the distance. So if I remember the distance formula, x1 minus x2 squared plus y1 minus y2 squared. So we know the distance in this case is 4. And we know x1 is 5 minus 3 squared plus y1, which is 4, minus k squared. So if we simplify this, we get 4 equals the square root. 5 minus 3 is 2. 2 squared plus 4 minus k squared. But we don't know what k is. We'll leave that alone for now. Now I'm actually going to square both sides, because if you remember, squaring a square root will get rid of it. So this will just leave me with 16 equals 4 plus 4 minus k squared. So if I subtract 4 from both sides, I get 12 equals 4 minus k squared, which I can then take the square root of. That will give me square root of 12 equals 4 minus k. But when you take the square root, remember it's plus or minus. So then if I rearrange this, I'll just subtract 4 from both sides. I'll get negative 4 plus or minus the square root of 12 equals negative k. And then just divide everything by negative 1. So k equals 4. Now if you divide a plus minus by a negative, it's negative, basically minus plus, so it's the same thing. So there's actually 2 points that I could have for k that would make it have a distance of 4. So if you have the distance, you can find the point, or if you have the point, you could find the distance. Almost always it's when we have the distance and we find the points, but this is just kind of another neat application that also helps us remember how to solve our quadratics. Our other formula is the midpoint formula. So if I have 2 points on the plane, and I connect them with the segment, I want to basically know what point is in the middle. So it's a pretty simple formula. The midpoint is always an ordered pair, and it's simply given by x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So if you look at these 2 points, I want to find the midpoint of these two. I already found the distance. So here's negative 2, here's negative 3, and here's 4, and here's negative 8, which is way down here. So I want to find the middle of those 2 points. Well, just like before, I'll call x1, y1, x2, y2, and I'll find the midpoint. So the midpoint, I add the x's, so negative 2 plus 4 divided by 2. Negative 3 plus negative 8 divided by 2. So that's 2 divided by 2, and negative 11 divided by 2. So that's 1, and that's negative 5.5. So if I go to that point on the graph, 1, negative 5.5, that's somewhere right about here. And I think we can agree that that looks like the middle of that segment. So 2 quick little formulas that we will actually use to develop what are called our conic sections here in the next section.